All right, now we have a topic where we're going to be comparing insulators and conductors. So starting off with insulators, we have some material where our charges are not moving. Something that might come to mind for an insulator is something like rubber. You can find that on your tires, oven mitts. And in my insulator, my charges aren't moving, so they're still. So what I want you to think about as I move through this video is if the charges are not moving, then what benefit is there in using an insulator, and when would you want to use an insulator? Think about that, and I will explain more when I show my demonstration. So over here we have conductors, where in a conductor we do have charges that are moving, and what I want you to think about on this side is if the charges are moving, then what benefit is there in using a conductor and when would you use it? So the main thing to consider here is how are the charges moving and what do charges moving or not moving do for us? Okay, so here's the first scenario to think about in considering our insulators and conductors. So here in this scenario, your sibling is trying to shock you. So your sibling here is a charged object, and we're not going to focus so much on what is going on with him. But over here, you're shocked, right? Not literally yet, but you don't know what to do. You're considering that it's going to hurt, and so you start to consider how you're going to protect yourself. So as your sibling's coming towards you, I want you to think about what you would do to not get shocked. Okay, so I hope that you thought of a way, because so has she. And so her idea has come to her that she will put certain clothing on to prevent herself from getting shocked. We have rubber gloves, rubber shoes, and a rubber hat. So now what we've come up with is that if we can cover ourselves in insulators to the best of our ability, when we get shocked, the shock will not touch our skin, but it will be absorbed in the insulator. So to summarize what has just happened there is a conductor has touched an insulator, and what happened is that these moving charges on the conductor were actually just absorbed in the insulator, and all of the charges are left here, but they aren't moving. So essentially you can kind of consider it as the charges get stuck to it and then nothing happens. So when our friend was trying to protect herself from her sibling, she put on things where the charges would be consumed rather than transfer to her skin. Okay, so now the second scenario to consider is if you're trying to shock your sibling. So in this case, you aren't the one being shocked, but it's not as simple as just holding a conductor and going up to somebody and touching them, right? So consider when you grab that conductor, are you going to be able to just carry it and go touch your sibling, or will it be too late? So instead of just holding the conductor like this, our friend is actually going to have to do something very similar. So in this case, our friend has had to put on rubber gloves and rubber feet and rubber shoes, because in order to touch this conductor, you need the charges to not transfer to your hands, because that would just shock you. So the idea here is that you want to grab it very quickly and touch your sibling, because if you hold it for too long, then the charges are just going to transfer to your rubber gloves. So it needs to be very quickly. And the rubber shoes may seem a little counterintuitive, but if your feet are touching, the charges will just flow through you into the ground. But instead, you want them to flow through you to your shoes so it doesn't shock you. So in this case, you have to grab it and move quickly and go and shock your sibling, because if you hold too long, you will actually just transfer the charges and lose it. So it has to be very, very, very fast. So to wrap up here, I'm gonna just provide a quick summary. So with our insulators, we were able to demonstrate that insulators will help us conserve our charge, right? It won't transfer very quickly. And something to note is that insulators can also conserve temperature. If you're familiar with Hydro Flask or any insulating coffee mug, that's something to consider, right? Sometimes it can keep your water really cold or your hot chocolate really hot. And I wanted to review some of the materials that are insulators because in this example, we really only used rubber to protect ourselves or to help us be evil. So in our materials, we could have rubber, we could even have wood or cardboard. So those are just a few examples. There are a ton. It would be great if you looked them up and help yourself get familiar. And to summarize our conductors, we learned that conductors can help us transfer charge because that would be the example of using it to shock someone, which is also the basis of a lot of electricity, which you will learn later in the quarter. And the materials that are conductive include aluminum, nails, like for construction, and keys. These are all materials that can transfer charges.